Electromagnetism is combination of electricity, electric field and magnetic field, and both are vector quantity. So to find the direction of a particle moving in a magnetic field, we use some rule. To find the direction of electric field, we use only, we don't need any rule, because which direction the force is, which direction the electric field, that direction is the force due to electric field. But in here we have so many rules: Fleming's left hand rule, Fleming's right hand rule, grip rule, right hand thumb rule, and right hand palm rule, and corkscrew rule. There are so many rules. Which rule is to be applied where? That is the main confusion. Need not to confuse. See, to find, first we will take up two rules. That is Fleming's left hand rule and right hand palm rule. This rule is used to find the direction of magnetic force on a charged particle. I repeat, the direction of magnetic force, that is Fm. Direction of magnetic force Fm. When a charged particle is moving in a magnetic field, we use these two rules. First rule, what it says? First we will deal with the Fleming's left hand rule. Left hand rule implies that we use left, not right. We use only left hand rule. In the left hand rule, see, we got 5 fingers. We don't need these 2 fingers. Close it. We need, that is thumb, forefinger. It is indicating you, forefinger U, like this. This is forefinger, and this is central finger. So we will use all this. We assume that in the left hand, the fingers of the left hand are mutually perpendicular to each other. That is, this is perpendicular to this one, and this is perpendicular to this one, and this is perpendicular to this one. So forefinger, central finger and thumb of left hand are stretched in mutually perpendicular direction to each other. So here, this is left, this finger mutually perpendicular to each other. The forefinger, this is most important. This will come later. This is first. This finger we will use first, forefinger. Then we will use this finger, and finally automatically this finger will give the direction of magnetic field, that thumb. Very simple. We need not to confuse anything. So we will take some example. See, before example, we will have some convention. Cross means, see, in 3-dimension, we cannot use 3-dimension in this 2-dimension board. Something will go into the plane of the board, something will come out of the plane of the board. Going in, that is going into the plane of the board, or in your notebook into the plane of the paper, this symbol we use, that is, it is going inward. This is inward. Same way, perpendicular to the board, inward is cross sign, and perpendicular to the board, outward, we use the dot sign. We use this dot sign. This is outward magnetic force. This is inward, going inside, and this one is outward. This symbol is used in all the books throughout. No change in this rule. First we will have a figure here, figure A. Here, this is the magnetic field. This is the magnetic field is given like this, and the velocities, we assume the velocity of the charge is moving like this. Charge is moving like this, and what type of charge? It is positive charge. See, we have for positive charge and negative charge. The direction of force for positive charge is in one direction, and the direction of force for the same condition for negative charge, it is exactly in the opposite direction. We use, again, see this finger, this is indicating magnetic field B. This finger, this is indicating magnetic field, this finger, and this finger, approximate figure, and this finger. Say it is all are mutually indicating. So all are mutually perpendicular to each other. This is forefinger, this is thumb, and this is middle finger, central finger, or you can call it as middle finger. So in this we use a simple Simple one. This indicates magnetic field. This indicates the motion of the charge, that is velocity, and this will give the direction of force. How we will use? You will use this one, FBV. FBV. Thumb, forefinger and middle finger. You have in this fashion, thumb, forefinger and middle finger, FBV. It means the middle, this finger indicates the magnetic field, and this finger indicates magnetic field, and this finger indicates the direction of motion of the particle, and this thumb indicates the direction of force, FBV. We use this simple method. So with this method, using the Fleming's left hand rule, we will find out for this figure. Here the magnetic field is cross, it means it is going into the plane of the board first. So magnetic field is into the plane of the board. Case A. Case A. This is case A. Now we will use this one, left hand rule. First we will use this, and velocity is in the upward direction. So first we will use this finger, middle finger we will use, and later second we will use this finger. Lastly automatically stretch it, that will give the direction of magnetic field. So first we will use this finger, magnetic field is into the board, and the velocity, this indicates the velocity. Velocity is in upward direction. We move it up. This is the direction of magnetic field into the board, and the velocity is upward, and this extended thumb gives the direction of magnetic field. So in this case, for case A, direction of F is left towards left, that is towards left direction. We will apply once again. This first this will come, second this will come, third automatically it will come. First this is the direction of magnetic field, then gives the velocity, because velocity is in upward direction, we will turn it like this, then extend the finger. After doing this, extend this thumb, that gives the direction of velocity. So the force, magnetic force is in this direction. First case. Second case. So this is here. Now we will see for B. B condition is, suppose this is for positive charge. For positive charge, direction of motion is towards left. Towards left for first thing. Second case, first case, second case, negative charge. If it is negative charge, we need not to struggle anything. That direction will be exactly opposite to the positive charge. For positive charge, using Fleming's left hand rule, this direction of FMS is in this direction towards left. For this, it will be exactly in the opposite direction. That's all. This is the first case. Now second, let us see. Now the velocity is in downward direction. The velocity is in downward direction, and we use positive charge. Second case, we call it as a B. B, this is positive charge. B is in this fashion. B is in this fashion, and velocity is downward direction. Let's say again we will apply. See, this is B, so as it is, B has not changed. So we use this finger first. Always point out B. And again we will take this one, this finger. This comes last. So we will rotate the hand like this in the direction of the motion of the charge. Then extend this one. This will give in this direction. In this case, the direction of FM is towards right. That is, FM is towards right. So if it is negative charge, suppose for negative charge, if you use negative charge, 3, 4 if you use negative charge with the same condition. Exactly, because this is this and these are conditions are same. Only thing the charge is changed. Exactly, it will be Fm. Exactly in the direction opposite to this one, in this direction. That is, this is towards right and this will be towards left. This is right towards right. This is towards left. Next, we will see the magnetic field coming out of the plane of the board. This one coming out of the plane of the board. First, let us see the particle is moving with in this direction. That is the velocity of the particle. That is, charge is moving in this direction and is a positive charge. First, we will see the positive charge and reverse the direction. In this condition, we call it as condition B. That is condition B. If this motion is in downward direction, first we will take it, we will take it in the downward direction. See, Fleming's left hand rule, we use this one, this is for magnetic field, and move this second, this one, then this will give automatically the direction of magnetic field. Now here this is coming outward, and this finger we will see show the velocity. Velocity is in downward direction, and we extend it. This is the direction of magnetic force. We can write like this for this one. For B, magnetic field B is in this direction, that is outward, and velocity is in the downward direction, and magnetic force is this one, magnetic force is in this direction. In this direction, it means that is giving the direction of magnetic force is in this direction. For this is for plus Q charge. Same way, suppose for minus Q charge, second we will use for minus Q. B is outward, velocity is downward. For negative charge, the Fm will be exactly, whatever is the direction, exactly will be in the opposite direction. This is the direction of magnetic force. Third condition, now suppose we will take the condition C. Condition C, we will take this is in the upward direction. Velocity is in the upward direction for positive charge. So positive charge is moving in the magnetic field. So for here we will see this is the first left hand. This is the direction of magnetic field, and this gives the direction of velocity, this finger. So we have to move in the direction of, then extended finger will show in this direction. This is the direction of force. It means force is in this direction. Force M is in this direction. That is for C. Magnetic field is in this direction, and velocity is in the upward direction. And for positive charge, and for negative charge, this is condition C. Same, magnetic field is outward, velocity is in the upward direction, and we want to see for the negative charge. Exactly reverse this direction, that is Fm will be in this direction. Very simple. For positive charge in this direction, negative charge with the same condition, negative charge it will be in the opposite direction. Now another situation, the magnetic field is in this direction and the velocity of the charge particle is in this direction. We have to find out the direction of magnetic field. See again, magnetic field is in this direction, velocity is in this direction. This will be outward. The direction of magnetic field will be, direction of magnetic field will be how? This way, it means outward. The direction of magnetic field will be outward in this condition. That is, this is the direction of magnetic field and this is the direction of velocity in this condition. This is for positive charge. Of course, for the negative charges condition is simple. This is the direction of magnetic field. Velocity is in the downward direction, and for negative charge, Fm will be in the opposite direction. See, here it is outward, it means it will be inward. This way, inward. Now let us take velocity is in the upward direction now. Velocity in the upward direction. This is the direction of B vector. This is a vector. That is why the magnetic force also having the direction. In this condition, the velocity, magnetic field is in this direction, and velocity is in the upward direction. Velocity is in the upward direction. Charge, it is plus Q charge. Plus Q charge, in that case, how we will find out this one? This is the magnetic field direction, left hand, and this upward direction is the charge, that is positive charge, and extended finger will be inward. The extended will be inward. It means that direction of motion, then the force on the charge particle due to the magnetic field will be inward. This is for positive charge. And same case if for negative charge. Let us take for negative charge. Magnetic field direction is same, and velocity also same direction, and the charge is minus Q. Therefore, the force, magnetic force direction will be, if it is outward, this will be inward. So this will be inward. Let us check up if it is for positive and negative charge. See, this is the direction of magnetic field, and this is the direction of velocity, it is inward. So this is the magnetic field, it is, and the direction of motion is upward, it is inward, it should be inward. And if it is inward, exactly opposite, it will be outward. This is the direction of, okay. We have taken magnetic field, previous one in this direction. Well, let us take in this direction. The magnetic field is in this direction, and let us take velocity in this direction for positive charge, and for velocity in this sense for negative charge. So in this case, how we'll do it? See, this is the direction of magnet, left hand, and in this direction of magnetic field, and velocity is in the upward, the finger is in outward direction. For this, the magnetic force will be outward direction. Same way for this, see, condition is same here, only thing in place of positive, negative charge is used, so Fm will be in this direction. In this case, magnetic force is in this direction. Let us take one more example. The magnetic field is in this direction, and velocity is downward direction for positive charge. Velocity is in downward direction. This is velocity, and this is minus Q. First case, for this, what is the direction of Fm? For this, what is the direction of magnetic force? So now you see here, this is magnetic field is in this direction. And this gives the direction of velocity, and it is inward. The thumb is inward. It means inward means the direction of effort means this fashion. Obviously, this will be outward for this. Except only thing, the conditions are same. Only thing, the charges are different. What is the direction of motion for this charge? It will be exactly in the opposite direction. Let us take one more example. Magnetic field is in the downward direction. Magnetic field is in the downward direction, and the velocity is in this direction. This is the direction of magnetic field, and if you use positive charge, so what we will do with this indicate magnetic field magnetic field, velocity is in this direction, outward. This is outward, means for this the magnetic force is outward direction. And if it is negative charge, B is same, but this is negative charge. For this case, the Fm will be opposite to this direction. Fm will be, if this is outward, it means this will be inward. The magnetic force will be inward, for this magnetic force will be outward. And we can, like this, we use only the Fleming's left hand rule for finding out. First, what you will do, the forefinger indicates in the direction of magnetic field, and orient it and rotate as per your convenience, but in the direction of velocity. If it is magnetic field is this direction, velocity is downward, this will be downward. The extended finger gives the direction of magnetic field. With this we can find out magnetic field, magnetic force with this left hand rule. Fleming's left hand rule, we can find out the Fleming's left hand rule. We can find out the direction of Fm. Of course, we will be talking about the right hand palm rule also. First we have dealt this one, palm rule. By combining either this one, wherever you find, sometimes you will find Fleming's left hand rule is very convenient. Sometimes you feel the right hand palm rule is really convenient. Whatever may be the situation, try to orient your fingers according to the situation of the magnetic field and velocity. Automatically you will get the directions of magnetic force.